Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabaz, as ever, I am the IT Geek. Welcome back to this SC300 Microsoft Identity and Administration exam series. We're deep into the series now, roughly halfway, and this is the last episode in Module 2 as well. So we've made some great progress, thank you for sticking with us. I am, like always, joined by my co-partner in this series, Dwayne Natwick. Hi, Dwayne.
Hey Shabaz, how you doing today?
I'm very well. How are you?
I'm doing good.
Good stuff. So yeah, Dwayne's been with me every step of the way. We've been covering. Dwayne's been really good covering the lab elements, and complementing all the theory we've been going through as well. As I said, this is the last episode of Module 2, and we'll be jumping straight into Module 3 straight after this. So yeah, without further ado, let's get started. So yeah, I will be doing an introduction of me and Dwayne again in the beginning of Module 3, but for now I'm hoping you still remember who we are just about. You will get that reminder in the next episode, do not worry. And we are still on Module 2, but this is the last episode of Module 2. And Module 2 is that implement an authentication and access management solution module. So we are the second part of the manage Azure AD identity protection. We looked at sign-in risk and user risk and that MFA registration in the last episode, the first part. We're going to look at monitoring, investigating and remediating risky users. We're then going to talk about implementing security for workload identities, followed by just a single demo in this episode, which will be monitoring, investigating and remediating risky users. And this is just to complement again the demo that Dwayne did in the last episode around those sign-in risks and those user risks, and let's actually looking and investigating. So we'll go through, Dwayne will hopefully go through the dashboard. So let's talk about investigating risk first of all. So identity protection provides organizations with three main reports they can use to investigate identity risks in their environments. Okay, the first is called risky users. So risky users, risky sign-ins and risk detections are sort of the three reports. Investigating events is key to having a better understanding of sort of your environment and identifying any weak areas within that security strategy that you've decided on. All three reports, allow you to download in that sort of CSV format, and that comes like a bit of a standard Microsoft thing, really. Anything you tend to download, be it the bulk user creations or guest user creations, all seems to be CSV. So that's kind of the format, and it's no different for these reports as well. One thing to note is that the risky users and the sign-in for your reports do have like a threshold. So you normally find 2,500 risky user entries, and for sign-in is normally the risky sign is normally sorry, let me go back. 3, 2, 1. So one thing to note is with the events and when you download that CSV, you'll normally get about 2,500 risky users and sign-in events. And then to complement that, you'll get about 5,000 risk detections as well. So these are all these are the number of records that you could see any one time in the CSV formatted file that you download. Just sticking with investigate risk, one thing I just wanted to touch on was the sort of Microsoft Graph API. So organizations can take advantage of that Microsoft Graph API and use it to do interrogations, essentially to aggregate data with other sources they may have access to, as part of the organization. Microsoft Graph, for those who don't know, is that Microsoft Unified API endpoint and the home of the sort of Azure Active Directory Identity Protection APIs. There are three APIs that kind of expose information about risky users and sign-ins, and they are called, I think it's called risk detection, risky users, and sign-in. So similar to what we just saw with the investigating risks, the API sort of APIs within Microsoft Graph are similar to that. With that risk detection API, it allows you to query a Microsoft Graph for for a list of both users and sign-ins that are linked to risk detections, and any associated information with that. With the Risky Users API, it allows you to query a Microsoft Graph for information about users that the identity protection has detected to be risky. So again, just wanted to spend a bit of time talking about Microsoft Graph API because it is kind of an important element of this topic. Just want to drill on risky users quickly. So with the information provided by the risky users report, administrators can find information around which users are at risk, or have had risk remediated, or have had to have a risk dismissed. Also gives you details, any detection details that might be in there, and history of any sort of risky sign-ins. And finally, it gives you a full history of the risk as well for that particular user. Carrying on with that as well, from an administrative actions perspective, they can choose, if once a risky user is sort of identified, they can choose to either, reset the password. They can confirm that the user has actually been compromised. So, when they're looking at that risk detection, they can look, okay, has it or has it not been compromised? If required, they can dismiss the risk. If it's not, or if it's just like a false positive, maybe, or they can actually block the user as well, the administrator. Or you can actually use Azure ATP to do some further investigation if you're still not happy. The action is, for any of the other actions are required, you can do further investigation and then decide what other action to take. So just same way we just talked about user sign-ins, let's talk about risky sign-ins. So the risky sign-in report contains filterable data for up to 30 days, okay, i.e. 1 month. And the information that's provided in it is, again, a bit similar, but again, what it shows us is the sign-ins that are classified as a risk, confirmed compromises, confirmed safe, any dismissed or remediated kind of sign-in attempts. Okay, so these are all like risk classifications. Also shows us any real-time and aggregated risk levels associated with sign-in attempts as well. Okay, so key thing there being real time. So we're getting real time information, which is quite important when you're trying to deal with, if your tenant has been compromised or not. So detection types can be triggered. And also you can apply conditional access policies to these risky sign-ins. So carrying on with risky sign-ins, there are a few more kind of elements that are in the report as well. You get details around the MFA settings that are configured for that sign-in. You can get details about the device that the risky sign-in was reported from. And also any application information regarding the sign-in, the sign-in risk and that took place. As well as, finally, the sort of location information around where the sign-in risk took place, physically or geographically, you could say. So the third item I want to talk about is the risky detection. So we talked about risky users, we talked about risky sign-ins. So I wanted to spend a bit of time on risky detection. So data from the last 90 days, whereas we saw with user sign-in it's 30 days, the risk detection report contains filterable data for up to 90 days. Okay, so that's like 3 months roughly. And the information provided by the risk detection report can basically show administrators the information about each risk detection, including the type, any other risks that have been triggered at the same time as well. So we're getting, not as well as the risky detection, we're getting any information about other risks that might have been detected at the same time. Gives us information about sign-in attempted from the location as well. So again, more geographical information about where that sign-in attempt was attempted from. The risk detection report also provides a clickable link to the detection in the Microsoft Defender for Cloud Apps, or MDCA. If it's not changed its name recently, that's what it is up until now. And this is in the portal where you can view additional logs and alerts. So let's quickly talk about remediation. Okay, we're getting towards the end of the theory. I'm going to hand over to Dwayne shortly. So all active risk detections contribute to the calculation of a value called user risk level. User risk level is an indicator. So again, we go back to those levels of high, medium, and low. And it's for the probability that an account has actually been compromised. As an administrator, you want to get all risk detections closed, because obviously if there's one open, then you still got a risk. So that the affected users can no longer be a risk. Some risk detections may be marked by the identity protection as closed because the events were no longer determined to be risky. So that the system itself can self-remediate and close it. Administrators have the following options when it comes to remediation. You've got self-remediation with risk policies. So if you allow users to self-remediate with Azure MFA, for example, and self-service password reset, if these are configured in your risk policies, they can essentially unblock themselves. So again, it's much more quicker than having an administrator do it. For a remediation option, you can get them to reset the password. So this is like a manual password reset. If requiring a password reset using user risk policy isn't an option, administrators can close all risk detections for a user with a manual password reset. Okay. They also have the option to just to dismiss the user risk. So when you do select this, all events are closed and the affected user is no longer a risk. So don't do this lightheartedly. Make sure you're 100% sure they're not a risk. What it doesn't do, because this method doesn't affect the existing password, it doesn't bring the related identity back into a safe state. So just one thing to note, if you just dismiss the risk. Finally, you can close that risk detection. So you can close individual risk detections manually. By closing that individual risk, you can lower the risk level. So if it is high, it could go to a lower one. So just need to keep that in mind. Final topic now, let's move on now to talk about that final topic, which is implementing security for workload identities. Let's try and understand first of all, what is a workload identity? It's an identity that allows an application or a service principal access to resources, and sometimes in the context of a user. There's, these workloads, they differ from traditional or user accounts. As they can perform MFA, or can't perform MFA, apologies. Often they have no formal sort of lifecycle process either. But one thing you need to be aware of is you need to store the sort of the secrets or store the credentials. So that could be in a key vault or something. Just some quick requirements when it comes to workload identities. Again, back to what Dwayne mentioned, that Azure ADP2 license. That's common theme in all identity protection. And again, you do need some assigned permissions. Now, this is, just be aware, this is, again, I'm going to caveat, this is the account that is doing the configuration, not everybody, okay? So one of those is obviously good old global admin, can't get away from that. You can also be assigned security admin, security operator, and security reader. So again, a bit more choice when it comes to assigned permission requirements. Again, these will have different levels as well. Obviously, we know global admin has access to everything. Security admin obviously has a lot less than global admin and just has any security features within Microsoft 365. Security operator again has less access than security admin. Don't ask me to specifically name what access it does have, but it does have less than security admin, but more than security reader, so it's kind of in between. Let's just discuss some of the types of risks that are detected before we hand over to Dwayne. So the Azure AD Threat Intelligence, this risk indicates some activity that is coexistent with known attack patterns based on Microsoft's internal and external threat intelligence sources. And it's also an offline detection type as well. Suspicious sign-ins, this is a risk detection. This indicates sign-in properties or patterns that are unusual for this service principal. And again, this is an offline detection type. We'll talk about unusual credentials. So this detection is discovered by Microsoft Defender for Cloud Apps. This detection identifies a suspicious addition of privileged credentials to an OAuth app. Okay, so again, talk about more modern ways of authentication. OAuth is one of those modern ways, authentication. protocols, and this is like kind of detecting any suspicious behavior around that. What this does indicate is that the attacker has compromised the app and is using it for, malicious / bad activity. And again, this is another offline detection type. And again, the account being compromised, this detection indicates as an admin has selected confirm compromise. So this is when the admin is confirming that the actual user has been compromised in that sort of risky workloads identity user interface. Or if they're using that, I think it's called the Risky Service Principals API. To see which admin has confirmed this account compromise, you need to check the account's risk history. You can do that via the API or the user interface. And again, this is also an offline detection type. So the final, I think this is the final one before we hand over to Dwayne, is leak credentials. So this risk detection indicates that the account's valid credentials have been leaked. And this can occur when someone checks in the credentials in a public code artifact on GitHub, for example, or when the credentials are leaked through a data breach. Okay, again, another offline detection type. That was a little bit of a more of a longer theory part, but it's demo time. Everybody's favorite time. So over to you, Dwayne.
All right. Well, you had a longer theory part. This will be a fairly short demo part. We're in identity protection again. We're really, you can see in the overview dashboard, it does put some of those risky sign-in detections and gives you a quick look. Luckily, my dashboard's pretty clean. I do have one in here, but we're going to go actually into the reports and see here. I actually have a count here of four protected accounts that and sign-ins that have caused an issue here. But we'll take a look at those here in a second. If I look at my risky users, you can see I do have an at-risk showing up in here. Low risk level. So even if you have a user risk policy that's set at high for user risk or medium and higher for sign-in risk, this is going to report at low risk levels as well. So you're getting reports in here, even if your policies aren't being triggered for somebody to re-authenticate with MFA or do a password reset. And if I select this, then I get some of that new information. I get the basic info, what the roles are, why it's at risk, and then get the recent risky sign-in. So you can see here, Azure portal, you see the IP address, you see what happened, and you can see that no conditional access applied here. I'm going to see probably that same risk if I go to risky sign-ins. That should report the same thing as well, and we get a little bit more in here in terms of device information, what the risk is. This is where we see the unfamiliar sign-in properties. You can see I'm in Michigan, USA, not in Chicago, Illinois. So it was flagged because of trying to log in from an unfamiliar place. Now I know, looking at this IP address, that this was actually one of my Azure virtual machines that I was logging into. So that virtual machine was located in Chicago, Illinois, and because I was using my sign-in credentials to log into it, and if you recall, that was the demo that I did in a previous section on using Azure AD to log into Windows devices. This was actually that sign-in that I attempted and to this IP address. So that's why it's at a low. Because I have multi-factor authentication. The fact that I already have multi-factor authentication is going to decrease my amount of user risk. And really, anytime any kind of these alerts come in, they're going to come in at low because I have MFA, and most risks are remediated by just having MFA in place in terms of a user risk. The risk detections, again, as Shabaz had said, we can do this as the last 90 days. We can only do 30 days for risky users and risky sign-in reporting. Again, we can see here, we get a little bit more information here that the risk type is atypical travel. I logged in from Michigan, and then a little while later tried to log into something in Chicago, Illinois after being logged in Michigan. That's why it's flagging this risk. Again, the IP address, the location, we get the request ID all in there. Same login information, 2 minutes apart. Still flagged it. The workload identity detection I don't have really enabled, but as Shabaz said, that's a preview feature here, and we can monitor, monitor secrets and logins from virtual machines to databases and things like that are, and find whether there's any risks taking place within those as well. We have our risk detection alerts in terms of notification, and notify those if a risk at medium or higher is detected, it's going to send me a notification. I didn't get an email on the risks that are showing up in the dashboard because I don't have it set for low. But if I get a medium or high, my 2 global admin accounts are going to get an email and let me know that, hey, there is an alert on a medium to high risk. So that's how you can work through and work around the dashboard. If I go back up here, we can, and you have the capability then to do additional information and drilling down in here. Here's where you would download those reports for your risky users, risky sign-ins, and that's about it. So I'll pass it back to you, Shabaz, to wrap it up.
Thank you very much, Dwayne, again, and that is another good demo again, just to complement what we were talking about in this episode. So, we had a bit of a longer theory this time, a bit of a shorter lab, but again, that's what me and Dwayne feel was kind of needed for this episode, a bit more information around the theory. So again, thank you very much, Dwayne. And yeah, that's it for module 2. That's a wrap for module 2. Bit of a longer module as well, so we did I think go over a week. I mean, we've tried to do a module per week, but I think we've gone over by a day just because we want to make sure we're getting you all the information, and if that means we've got to do an extra episode here or there, then so be it, as long as you guys are getting the correct information. So all our socials are in the description, LinkedIn, Twitter, etc. The most important link is to Dwayne's SC300 exam book that he's written with Pact. So that is available on Amazon. Please do buy it and work along with us while we're going through the videos. And also a link to the SC300 GitHub labs as well. You can follow those labs along with us as well. But yeah, thank you everybody for watching. Please do like, comment, and do not forget to subscribe. But up until next time, thank you and goodbye.
Thanks, everybody.